In this part of the oceanographic training module, we're going to go over the second worked example. So this is assignment 2. It's working with a surface mooring. So this is based around the Southern Ocean Flux Station sample mooring profile, which is in full ocean depth and makes many measurements in the upper 1,000 meters of the water column. So the context for this analysis is that some preliminary design is completed, but there needs to be a check on what happens with the mooring watch circle in the design current profile, and then the peak loads in a couple of different sea states. So there's some environmental conditions given, and along with some expected results. So you can use the same Southern Ocean Flux Station file and in fact just copy it and paste it into a working file. So this is downloaded off the website. This is Cyro Soft's the 5th version of this mooring, and we'll just copy it into Surface A, this folder here. Right. So there's quite a lot of connectors and components in here. We're going to leave them as is, and this is purely a process of going through and completing the analysis. So let's double check the water depth is the same, and we have the same current profile parameters in here. This is the same on the bottom, so that won't make any difference. That's fine. Okay, so the first thing we need to do is calculate the static mooring profile. So we'll click on Export and Static, and we just hit Run. And we'll let this run for a little bit and check on it and on the results soon. Okay, so some time has passed and the static profile of the soft moorings has been calculated. So let's take a quick look and see what it looks like in PostPDS. So click on the PostPDS button, use the default loading options, and it's such a big mooring, it's really good to jump to engineering, and in the East view, make sure you're in orthographic view as well. So here's the straight line input for this mooring, the profile in 0 current, and then the profile in the profile of the mooring in the specified current profile. So that looks right for this kind of configuration. To verify the watch circle, we can run the report tool and surface quasi-static cable single leg mooring. Use the default parameters. Generate the report from the data that's been generated from the simulation, and under the steady current condition, we want to look at the horizontal deflection, and we've got the top buoy here, so a total horizontal deflection of about 3.4 kilometers, and that's the expected result here, so that's good. Now we need to set up several different sea states to evaluate the peak dynamic loads for this system. So there's a 3 meter significant wave height 8 second, 9 meter significant wave height 11 second peak period, 20 meter and 18 second peak period. Now according to the wave steepness, the largest steepness of all of these, just based on this formula here, is sea state 2. So I would expect to see the biggest accelerations and the biggest loads from this condition. But we can check and see what happens based on looking at these different results. So we'll want to check different realizations just to make sure we've got like a nice, comfortable capture of the peak dynamic load and get a feel for the variation in the peak dynamic loads across this irregular sea state. So to set that up, what we're going to do is use this static profile as the starting condition for the mooring. So we'll go, I'm going to call this dynamic, export. Remember, export takes the final state of the simulation and creates a new project for it. So to set up a dynamic, the first thing we need to do is convert the static model to a dynamic cable. Okay, you see that change from quasi-static cable to cable. We'll need to change the simulation length. It's suggesting a 500-second simulation length and 0.1 second output rate just to capture the dynamics and make sure we've got a reasonably long simulation. Again, you can kind of gauge how the peak loads change when you change the simulation length for your own mooring. So now we want to, we'll set up a so we can right click and go available values. We'll just use a John swap for now. Resolve follower properties. And the first state here we're going to look at is the 9 meter 11 seconds. So we'll do 9 meter 11 second, and I'm going to set the first seed as 111. We've left this at 50 wave segments as well as it's specified in the problem. So we'll go save. We'll close all these windows. We don't need any more. So I would recommend making a few subfolders here for each C state because it does get a little disorganized otherwise. So we'll call this C state 9 meter, and I'm just going to drag that into there. We might even rename this with just seed 1 on the end. Now we can Control-C, copy, and paste. Paste again. Now I'm going to change the parameters in here to make the different realizations. So we go to C2, we can open Proteus Simulation Toolbox. The only thing we're going to change now is the wave seed. So go 222. I mean, as long as there's a different number, we're going to get a different realization. That's the main kind of important thing. We do the same thing here. Scroll down and change this wave seed 333. Okay, now we've got all of our C state with 9 meter C state properties set up. Now we can, a quick way to do this is we can go through and just make a copy of this folder. Now what I want to do is change the C state intensity here. So we've got wave height for the next one is 3 meters 8 seconds. 3 meters 8 seconds. Now note that these are text files, so if you want, you can, if you're comfortable, you can change them here. 3 meters 8 seconds. Sometimes it can be a tiny bit faster, but just make sure you don't have Proteus Simulation Toolbox open. So only if you're comfortable doing that. So we'll change that to 3, go to 8. Okay, now, and already the different seeds have been established. We don't need to change anything there. And we'll try the final C state. So this is the 20 meter. Oops, let's just change that there. Okay. So this last C state has 20 meter significant wave height and 18 second waves. I know it really seems like 20 meters is a really high wave height, but the thing is, the steepness is the wave height divided by the wavelength, and I mean those 18-second waves have a really substantially long wavelength. That's what makes it, the steepness just isn't quite as high, you know. But yeah, I mean it does really seem like a huge wave height. Okay, and we'll go through and change this to 20, 18. Don't change these files if you have them open in Proteus Simulation Toolbox because they're going to get overwritten. So if you're not comfortable or unsure, just open them up in Proteus Simulation Toolbox. 15 seconds, there we go. Okay, Now, there's 3 sets of cases inside each sea state. That's quite a few. You can open them and run them individually, but it's kind of a challenge to do that. Alternatively, you can use ProteusDS Queuing Manager. And if you're not, that's what the icon looks like. If you're trying to find it, ProteusDS Queuing Manager, just type in the Start menu and it shows right up here. Now the great thing about this is you can select your folders and just drag and drop them in here, and they all show up. And then you can pick how many cores you want to use to run the cases here. So depending on how much time you have and whether you're on a time crunch, it's a really handy tool to manage all this. So let's get them running. Alright, some time has passed and our simulations are complete for the 3 different sea states and 3 realizations for each one. In PQM, you can spot check the results by highlighting one of them, right-clicking, and going View Results in Post-PDS. At this point in time, you may want to consider loading only a small section of time, just to speed up the loading process and just get a quick check on what's happening. But we're going to load the whole data set. This will give us a chance to take a look at what it's doing in the sea state, and we can also do some basic plotting to get an idea of what's happening, particularly with the mooring reaction loads at the top of the mooring, where they tend to be the largest. Once we've loaded it, we'll take a quick look at what the mooring looks like as the buoy is moving around in waves. Alright, there we are. And then we'll look at a plot of the tensions. So this is perspective view, which is a little bit more, it's a realistic sort of perspective view of what the system looks like in waves. So we can jump to any time and play back what the simulation looks like. The buoy's doing a good job of following the waves in this condition. So this is the sea state with 20 meter significant wave height. You can change it to engineering view, which may run a little bit faster depending on what you're looking at in terms of hardware for your video card. You can change the grid size and resolution as well. It runs a little bit faster on this computer, for example. So it's a very long mooring. Again, we can look at the side view and change it to orthographic and get a sense of what's happening. So the mooring is so long that even these 20 meter significant wave heights are not that big compared to the total water depth. To get a look at what the time series tension looks like, we can right click in the tree and go plot tension and tension versus time. By default, ProteusDS Oceanographic Designer configures things so that the first element is at the top of the mooring. So you can kind of get a sense of what the load variation looks like in this condition, and then there's the sort of maximum value there. And if you look at your expected results for this, should be the 3rd seed in the 20 meter significant wave height. I mean that's pretty close. You can left click on the peak and see what the values are. That's 36 kilonewtons, which is the expected result. So it's nice to look at this. Note there's a peak at the beginning. This is an artificial transient that you get from switching from the static model to the dynamic model. Don't forget we're also ramping up waves. Both of these are good reasons to truncate the analysis with the report tool by the first 10 seconds at least. But again, just to emphasize, it's really important to look at more than one realization because the peak's in the middle of the simulation, but you don't know where it might be, and you want to run a long enough simulation, and it's just good practice to run more than one realization to make sure you get a good idea of what the peak loads look like. So how do we automate this process in terms of looking at the results and reporting, because I don't want to have to load the data and eyeball a plot each time? Well, that's where the report tool comes in. So we can right click again and go View Input Folder. Now the report tool is accessible by Proteus Simulation Toolbox. So you'll see that we didn't run the simulation in Proteus Simulation Toolbox, but it shows that the results are done, and you can open the report tool this way. So the report tool, we've got a dynamic set of data, so we want to pick single leg mooring. Here's where we want to truncate the first 10 seconds. I'm picking 10 seconds because that's what we were ramping the waves up, and I know there's that spike at the very beginning from switching from static to dynamic model. If you wanted, you could adjust this and make it longer, but it's just going to ignore the first 10 seconds of data. And if you want, you could report the results in kilonewtons. So we'll just hit generate and see what happens. These reports take a little bit longer to run because there's just a lot more data to go through. So it's reading all the data, it's calculating maximum, standard deviations, and things like that. And it's just a little bit longer than the static analysis. So this is a pretty standard report, and there's an echo back of the engineering model of the mooring. And what we want to do is jump down to cable segment tensions. Now these are the different line properties here. This is the part that's right at the beginning, and you can see the maximum in the whole simulation is 36 kilonewtons. There's some statistics on the reaction loads. You get standard deviation as well, and the maximum, around that, the mean value as well. So that's what we're looking for, is this 36 kilonewtons value. That's lining up with the seed 3 expected value from the 20 meter significant wave height result. That still takes a while to go through. If you really want to open each Proteus simulation toolbox and work on the click on the report tool button, there's another way to run the analysis using the report tool directly. So let's type in ProteusDS report tool in the start menu. The great thing about working with this directly is you can pick your template, single leg mooring, and then we can go back to, for example, we'll just pick sea state 3, and you can drag and drop that in here, and it's loaded up each. It's checking that there's 3 simulation folders and loading them up in here. So I'm just going to process these ones for now, but I mean, you can run the processing on your own computer and see how it goes. We'll do the same thing here. Report start time 10 seconds. So it's going to apply these settings to all of these and process them in a queue. I'm just doing 3 now because it's just a little bit faster for the purposes of demonstrating getting the results here. So go generate. So now it's going to batch process all of those results, and then we'll compare. Let's see here, peak loads from sea state 1, 3 meter, 8 seconds. So we should see these results for the maximum loads. I'll just take a moment to load those results. And again, it's scanning through the results for each of the simulation results and then generating the report. There we go. So we can click on an individual one and click view. So this first one is seed 1, seed 2, seed 3. Oh, it's loaded all of them. Oh, because they're all checked here. And then you click view and they open them. So we've got seed 1 results. Again, there's the random wave number seed 111. We'll just jump down to the cable segment tensions here, and we've got oh, that's the watch circle. I scrolled down a little too far. Here we are. The tensions in kilonewtons. So seed 1, 21 kilonewtons. That's as expected at the top of the mooring. Seed 2, cable segment tensions, maximum 24. That's as expected for seed 2 for the 3 meter significant wave height. And then seed 3 for the, and again, remember the environment properties are echoed here at the top. 3 meter significant wave height, 8 seconds. And here we have 23 kilonewtons peak load there. So just looking at these, this starts to build confidence. Okay, I think we've got an idea of what the peak load is in the sea state, and you have to use your judgment to pick. You can be conservative and pick the worst 24 kilonewtons load out of this for gauging safety factors and loads. And of course, what you can see is as expected from the wave steepness being highest in the 9 meter significant wave height. These are where the biggest loads are. So yeah, so that was the working through an example and resolving peak loads in one of the example moorings that's available. Thanks for watching.